Hello, my name is Perla Vega, and my research presentation is about the spleen and gamma radiation. The immune system is a system that protects you from any foreign invaders and mostly keeps you healthy throughout your life. It does this through white blood cells and lymphocytes. The white blood cells and lymphocytes help off fight all the viruses and pathogens that come in through your body. There's different stages that they do this through. There's like inflammation, where either your skin becomes swollen, that's why you see that, or you have a fever to help with fight. Those are some of the stages that the system does. And really interesting fact about the system is that it's a very highly radiosensitive, so any small trace of radiation can compromise or cause its functions to be suppressed and later on affect the whole body, which can make you sick most of the times. So any small trace of radiation, like I said, can compromise it. The spleen, being part of the system, one of the largest lymph nodes, it creates lymphocytes and destroys old or damaged red blood cells. It also stores red blood cells if it sees that the body is losing too many red blood cells. This is when you start hemorrhaging or you have a large loss of blood. It saves them to later on use them when they really need to. Radiation is seen everywhere in your daily lives. Radiation can be eaten. You can be exposed to it through daily activities, such as maybe using the computer, or it can also be exposed through environmental ways. The main way that radiation is exposed is through the medical field. Radiation is used to diagnose and treat different diseases. For example, cancer. 39.8% of men and women in the United States are predicted to get cancer in their life. And of those 39.8%, 50% of them will receive radiotherapy to treat their cancer. Radiotherapy is a precise treatment to attack the cancerous area and usually consists of gamma radiation and X radiation. 2.35% of the people who get cancer are going to have abdominal cancer, where the spleen is located. Abdominal cancer usually consists of stomach cancer, intestine cancer, spleen cancer, kidney cancer, any organ that's really in your abdomen. Like I mentioned before, any small trace of radiation can compromise and later on affect the system, the immune system, specifically the spleen. Since I know we mentioned that radiotherapy can be precise, but it has been seen, especially by the National Institute of Health, that radiotherapy, although it is precise, it can expose the surrounding tissues of the cancerous area and affect it and damage them through radiation. It doesn't necessarily only kill cancerous cells, it can also kill healthy cells. So if the spleen is close to that cancerous area, it exposes the spleen, and because the spleen is radiosensitive, like I mentioned before, it compromises it. Like our first source, created by Richard P. Spencer, they have 3 different women, the cases from women being aged 73 to 45, and these women were exposed to gamma radiation through a gamma camera. The first woman, being aged 73, was exposed to 3,500 R radiation. R radiation is the larger unit of radiation that a human body is exposed to. They saw that her spleen went from 20 centimeters to 14 centimeters. The next case, a woman being aged 63, exposed to 1,400 radiation, her spleen went from 11 centimeters to 6 centimeters. And the last woman, age 45, she was exposed to 3,600 R radiation. Her spleen went from 14 to 12 centimeters. All these 3 women came into the hospital with abdominal cancer and were treated through a gamma camera, which is basically like an MRI that just exposes the whole body to radiation. They later on saw the blood counts of these women, and they saw that the white blood cells also decreased after the exposure of radiation, along with the spleen. The second source talks about the effects of low dose radiation on the leukocyte counts and the spleen on mice, and they tested 200 mice. They split them in 4 groups. Group A being the control group, Group B, C, and D being exposed to 5, 50, and 100 C gray radiation. C gray radiation is the amount of radiation that is absorbed by the body of the organism, in this case the mice. After the exposure of radiation, it was seen that the leukocytes and the spleen, all the leukocyte counts and the spleen decreased when they were exposed to 100 C gray radiation after the exposure of that 100. And this was after 14 days, actually. They started seeing a change. For the last source of my literature review, they saw the effect of radiation on lymphoid organs and lymphocytes, and they also tested on mice. However, they split these mice in other different groups, and they were exposed to different amounts of radiation. It was 0.5, 1.5, and 3 gray radiation of gamma radiation. They saw after the exposure that a decreasing number in leukocytes and lymphocyte counts, and they also saw a decreasing number in the spleen as the amount of radiation increased. All these sources were from different authors, obviously, but they exposed their organisms to different amount of radiation, and they got similar results to each one of them got similar results to each other. Yeah. For my research question, I am researching if does radiation cause a change in the mass of the spleen on cancer patients with abdominal cancer that are treated with radiotherapy that contains gamma radiation. For my methodology to find all the sources, the database that I mostly used were PubMed, Loyola University database, and Rice University database. Usually, the keywords that I used to further narrow my sources were I looked up gamma radiation, mice, spleen, and radiotherapy, along with other keywords, but those were the most used keywords I used. To further narrow my sources from that result, I used peer-reviewed sources along with a complete article to download the full text of the sources to read them completely instead of just having the abstract. The method of each source that I used for my results and for my literature review, their method was that they divided the mice in different groups to expose them to different amounts of radiation. After they exposed the mice to different amount of radiation, they saw the effect of the radiation through a certain amount of days. Usually the amount of days that these mice were exposed to radiation was about a whole month, so 30 days. Later on, they concluded and got the results from the experiment, and most of them, it was seen that they had similar results. After I gathered all these results for my methodology of everything I gathered, is that I put all the results in a table that has 3 columns consisting of 3 sources and 5 rows. Each row has a certain is dedicated to a certain data that I gather from each source. Row number 1 has the amount of radiation that the mice were exposed. Row number 2 has the size of the spleen, or either if it was decreasing or increasing. The third row has the white blood cells, the fourth row has the red blood cells, and the last row has the lymphocytes. For my later on, I will compare all these sources and all the results that they gathered and make a conclusion out of there. And yes, for my prediction, this is an example of the table I predict it's going to look. That as the amount of radiation increases, the amount of spleen size decreases, the amount of white blood cells decrease, the amount of red blood cells increase, and the amount of lymphocytes decrease. Why do I believe that the red blood cells will increase? Because like I mentioned before, the spleen destroys old or damaged red blood cells and also stores them. So if radiation is gonna compromise its function, it will no longer be able to store all those red blood cells, and it will no longer be able to destroy old and damaged red blood cells. So all those red blood cells will continue on circulating the system without helping the system at all. So that's why I believe that the red blood cells will be increasing as in comparison to the rest that will be decreasing. As the results that I gathered from all the three sources, I saw that for system number 1, the effects of ionization radiation in the immune system with special emphasis on the interaction of dendritic and T cells, which is seen in the immune system, they tested the mice with 2 to 3 gray radiation, and they saw that 2 to 3 gray radiation was the largest amount of exposure that these mice were exposed to. They saw the spleen size decrease, the white blood cells decrease. I couldn't find anything with the red blood cells, and the lymphocytes decreased. For the second source, it being the doses affecting the lymphocytes and lymphoid organs, 3 gray radiation being the largest amount the mice were exposed to. The spleen size decreased, the white blood cells decreased. I couldn't find anything for the red blood cells either, and the lymphocytes decreased. For my last source that I put on the table, talking about the gamma radiation affecting leukocytes and spleen size, it was seen that the spleen size decreased as the amount of radiation increased, and these mice were actually exposed to 100 C gray radiation, which was the largest exposure amount. The white blood cells decreased, the red blood cells decreased, and the lymphocytes decreased as well. The red blood cells decreased because the red blood cells were just dying after a while, and they were dying faster than were being produced. The limitations I got are that the amount of radiation the mice were exposed to are different in each source, and that how the mice were exposed was also different. The mice could have been exposed through a capsule that is injected to a certain area of the mice, or they could have been exposed to the whole body, which is either through air or like a little MRI that exposed the whole body of the mice. Implications were that gamma radiation was seen to affect the immune system, and it weakened the organs in the system, which reduced the production of the blood counts, like white blood cells, red blood cells, lymphocytes. Why am I doing this? I want to bring awareness to cancer, how we treat cancer patients, especially abdominal cancer that has a spleen. Patients are already living with the burden of having cancer. They shouldn't be living with the burden of having a weak immune system and constantly worrying about that immune system, constantly getting sick. So I want to encourage doctors to find a new way of treating cancer, a pharmaceutical way, a different way other than radiation. Thank you. Here's my works cited.